Hi friends, in the previous section we have seen what is DevOps and why DevOps. In this section we will see what is Docker and why Docker. So let's start with what is Docker. Docker is an open source platform that enables developers to automate the deployment, scaling and management of application inside lightweight portable containers. It was introduced in 2013 and has since become a popular tool in the world of software development and DevOps. Now, if we pick one word from this definition, it is a portable containers, which makes all the magics. So let's see first what is containers and then we will see that how it gives us portability. So let's take an example that you have two different application A and application B, right? Both is running with same software but with different software version. For example, application A requires PHP and MySQL with version X. Application B requires PHP and MySQL with version Y. So we have same software for both the application but both requires different versions. Now if you try to achieve it without containerized system, it is very difficult for you to achieve this within the single system because both software versions have different dependencies and it may conflict with each other because just try to install two different PHP versions or two different MySQL versions within the same system. It will be very hard for you to maintain and install. Instead, what Docker will do that Docker uses containerization technology which allows application and their dependencies to be packaged together in a container. You can understand container as a box where you put your application and all its dependencies within that box which does not conflict with another containers. That means both containers have different software versions without conflicting with each other, and hence it is allowing you to run as many applications as you want with different software versions without conflicting with each other, and that gives us the real time isolations, right? The another advantage of Docker is that it gives the portability. How? Containers run consistently across different environments, making it easy to move applications between development, testing, and production systems. How? Assume that you are developing your application into Windows system and then you are deploying it to the testing and production where it has Linux operating systems. So you can see that you are running your application in the different environments which have different operating system and it may have different versions of the software as well, which leads to unexpected bugs. So to avoid this, if we use containers, right, it runs across different operating system with same software versions and same libraries. In this way, it is giving us real portability, which means that you are writing and running your code in the local machine within the same containers, and you can easily move these containers into the test and production system. So your test and production code will also run within the same software version and with the same libraries, and hence you are getting the real portability. So it is called the portable containers, right? So In the Docker, if we define it in very short terms, it will gives us real portability and the isolation. Right? But don't worry, we will see each and everything practically in upcoming sessions. So this is all about Docker. In the next section, we will see what is Kubernetes and why Kubernetes. See you soon. Bye bye. Hi friends. In the previous section, we have seen that what we are going to cover in this course. Today we will see all the WH questions like what is DevOps and why DevOps. So in terms of definition, DevOps is a set of practices and methodologies that combine software development and IT operations to improve the efficiency, collaboration, and overall performance of the software development lifecycle. Now, let's try to understand each of these words in the detail that how it improves the efficiency, how it improves the collaboration, and how it improves the overall performance of the software development lifecycle. To understand this, we will take one simple example. So, as we all know that how the traditional software development process works. For example, you need to fix an issue which is urgent and you need to fix it outside of your working hours. Now, you already fixed it. Next, you need to contact the quality assurance team to approve it. Once the quality assurance team will approve it, you need to contact the deployment team to make it live. And you also need to provide the steps to the deployment team that how to make this issue live. So, even if it is urgent, you need to contact many teams. And if some team members are not available in time, it will lead to delays. And if in urgent cases, if it is not communicated well with each team due to its urgency, it will lead to miscommunication. And finally, due to these two things, it will lead to inefficiencies. So instead, DevOps is suggesting that we will automate these two processes, that is the integration process and the deployment process. Now the teams are still there, but their responsibilities will be changed when it comes to DevOps. How? Let's see. The responsibility of development team is to write the unit test together with the code. The responsibility of the testing team is make the automated test cases using the tools like Cypress and Selenium. The responsibility of deployment team is to set up an infrastructure which will do the automatic deployments using the tools like Jenkins and GitLab Actions. So in this way, DevOps has defined the best practices, and if we follow them, we will get best out of it. Now, when we talk about DevOps, we often heard two words that is continuous integration and continuous delivery, right? So, what does this mean? Continuous integrations means as soon as we push our code into the centralized repository, it will automatically test our unit test and it will catch any issues early in the deployment process, right? How? So let's again take an example. that you have one urgent issue to fix on live, right? You have completed your code, and as soon as you push your code into the repository, it will automatically trigger the automated test cases, and hence you don't need to wait for quality assurance teams. So that is called continuous integration. Then it comes to continuous delivery. As soon as your automated tests are succeeded, right, it will trigger the continuous deployment process, which is also automated. So you don't need to wait for deployment team. In this way, we are removing the dependency of each team, and you make your urgent issue live in timely manner. So these are the real advantage of DevOps. DevOps is suggesting many practices, and one of them is infrastructure as a code. Let's take example that if we have a person X who has set up all the server of our organization and that person has left the company, what will happen? No one knows that what he did. Instead, if he has set up the infrastructure as a code, right, it is there in the version control system, anyone can manage it with efficiency. So that is again one of the best practices to follow in the DevOps, that we set up all our infrastructure as a code using the uh, supported languages like a Terraform, Ansible, and so on. Let's move further. As we already seen that automated testing is a must in the DevOps environment. Now, DevOps is also suggesting that we will put automated monitoring tools in place. Suppose there is an issue in live or in the productions and you need to fix it urgently, but you need to first investigate it by looking into the logs. Then, in the traditional software development process, you need to contact the deployment team, and the deployment team will give you the logs to review, and then only you can find the issue. This will take a lot of time. Instead, if there are monitoring tools in place like Greylog, Grafana, New Relic, etc., which can be accessed from anywhere by anyone without logging into the server, as it is already integrated into the server by the deployment team. So each team have access of the logs like a development team, testing team, and deployment team, and they can spot the issue as early as possible, and that is also without dependency. So these are the certain practices that DevOps is suggesting to follow. Now, due to the nature of the DevOps, that it helps us to quickly test and deploy the changes into the live, it is really aligned with the agile principles where customers feedback are so frequent, and hence we can easily achieve it without delay. So the DevOps is really aligned with the agile principles. So we should follow the DevOps best practices to achieve the quality and the speed. So that is all about DevOps. See you soon in the next lecture. We will see for the Docker. Bye bye.